In today's lesson, we're going to take a look at some of the properties of polynomials. You're familiar with many of these, and much of this will be a review. There are important ideas, important properties that you need to know in order to work successfully with polynomials. I recommend watching this video and taking good notes, even if you think you know what you're doing. There are several pieces of information that you haven't seen before that you want to make sure that you know. Let's just begin by defining what a polynomial is. A polynomial is simply a string of little packages or a string of separate pieces. Look at example 1. We have 4 separate pieces here. We have 3x squared, 2y, 7xy to the third, and 5. 4 separate pieces. Each of those pieces is called a term. Terms are separated by addition or subtraction symbols. Take a look at example 2. 5r to the 5th plus 7r to the 3rd minus 8r squared plus 7r minus 302. How many terms do you see there? Well, there's a total of 5 terms. Each of those terms is separated by addition or by subtraction. How about example 3? While it's a very long term, there is only one term. There's no addition or subtraction separating everything, so it's just one big piece. Now let's take a look at something that I know you remember. This is about like terms. You know that when you combine like terms, you look at the variable and the exponent. Here we have 3x squared and we have minus 2x squared. Because they're both x to the second power, I can combine those numbers. 3 minus 2 is 1, x squared. Now let's look at the 6x to the 4th and the 3x to the 4th. These are like terms because they're both x to the 4th power. 6 plus 3 is 9, so I have 9x to the 4th. Now I have a minus 7x, and since that's the only thing with just an x, I'll just bring it right down. There's nothing to combine it with. And the same is true for the 2. There's only one thing that has no variables, so I'll just bring that down with me. Now, in this case, I have multiple variables, and this can be a little bit more tricky. We need to find exactly the same variables with exactly the same exponents. Notice here we have 3x to the 1st, y to the 5th, and on the other side we have negative 12, x to the 1st, y to the 5th. These are like terms because they're both x to the 1st, y to the 5th. 3 minus 12 is negative 9. There's nothing to combine the other two terms with. The 5x to the 5th y doesn't match up with anything else, and neither does the minus 7xy. So we just brought those down. By the way, sometimes you may not have like terms to combine. If you look at example 3, there are no like terms, and so there's nothing I can really do with that polynomial. So you might be wondering how we describe polynomials. We usually describe them by looking at their exponent. In the case of negative 5x to the 7th, we say that that is of the 7th degree, the 7th degree being the exponent. If you look down further at 9x squared y to the 4th, well, because I have 2 variables and 2 exponents, I just add the exponents together. 9x squared y to the 4th is a polynomial of the 6th degree. How about 3x to the 12th? If you said 12, you're correct. How about 7a to the 9th, b to the 6th? If you said 15, you are correct. So you might be wondering how we go about describing polynomials. We usually describe them by talking about the degree. Negative 5x to the 7th is of the 7th degree. Notice that the degree is the same as the exponent. If we have 2 variables with 2 exponents, such as 9x squared y to the 4th, we simply take the 2 exponents and add them together. 4 plus 2 is 6th, so this is of the 6th degree. How about 3x to the 12th? If you said the 12th degree, you're correct. How about 7a to the 9th, b to the 6th? If you said the 15th degree, you're correct. We simply added the 2 exponents, the 9 and the 6 together. By the way, you might be wondering, what if there is no variable, such as the number 12, be of the 0th degree? It's like saying we have 12x to the 0. We know that x to the 0 is 1, and so we simply have the number 12. We can describe polynomials based on the number of terms they have. If we have only one term, such as x squared, we have a monomial. If we have two terms, such as x squared plus 2x, we have a binomial. If you have three terms, such as x squared plus 2x minus 4, we have a trinomial. Notice that binomial starts with bi, which means two. It's like a bicycle. 2 wheels, binomial, 2 terms. Also, trinomial starts with tri. Tri means 3. Tricycle, 3 wheels. Trinomial, 3 terms. When we write polynomials, this is an interesting little fact, there is a standard form we follow. Usually we write it with the highest degree first. So in our first example, we have 3x plus 7x to the 5th minus 8 plus 37x to the 8th. Well, we take the biggest one and put it first. That's 37x to the 8. The next biggest exponent, 7x to the 5th. The next exponent, 3x. And finally, minus 8. The degree of the polynomial is given by the biggest exponent. Because the biggest exponent is 8, we say that that polynomial is of the 8th degree. Remember, the degree is given by the sum of the exponents if you have two variables. 17xy has a degree of 2. 12x to the 5th y squared has a degree of 7. 32x to the 4th y to the 7th has a degree of 11. And we simply put them in order from the highest degree down to the lowest degree. By the way, the degree of the polynomial is 11 because it has the largest degree being 11. Some important things to remember when you're adding and subtracting is that really all you're doing is combining like terms. In the first example here, I have 6n and minus 4n. That's 2n. I have a 2 and a negative 6. That's minus 4. And I have 8x squared. Example 2 is very similar. There's a parenthesis there, but it doesn't really mean anything. I'm simply combining like terms. 5x squared, and then I have several things with just an x in it, minus 4x plus 2. Example 3 is a little interesting because you notice there is that subtraction sign in front of the parenthesis. We have to use the distributive property in order to work with this. When we use the distributive property, we have 3n minus 2n squared plus 3n plus 2 plus 2n squared and plus 2 that was already at the end. Then we can combine like terms, and now we have our answer in simplest form. Example 4 is for you to try. Once again, you see there's a minus in front of the parenthesis. Don't forget to use the distributive property. Please pause the video here. We use the distributive property. That gives us a negative 2x and a positive 3y. We combine like terms. We have 5x squared y minus 5x plus 3y plus 9. On the next page, we have a little bit of subtraction. We have two binomials, 2y to the 3rd plus 6y squared minus 3y squared plus 2. In example 2, we have 4x to the 4th minus 2x squared minus 3x to the 4th minus 2x squared minus x. Notice that in front of those parentheses is a minus. When the minus is in front of the parenthesis, you have to use the distributive property. Please try either one of these examples, pause the video here, and then come on back. We'll see how you did. In our first example, we end up with 2y to the 3rd plus 3y squared minus 2. In example 2, we end up with x to the 4th plus x. And so here's what you need to know. Polynomials consist of several terms. Each term contains numbers and letters known as variables. When you're working with polynomials, each term is separated by a plus or a minus. When we talk about polynomials, we can name them based on the number of terms that they have. A polynomial with only one term is a monomial. If it has two terms, it's a binomial. 3 terms, it's a trinomial. Other than that, we just call them polynomials. We can describe polynomials based on their degree. Typically, it's the degree of the largest term. Degree is the exponent on the term. If we have more than one variable in a term, we add the exponents together, and that gives us the degree. Final thing you need to know is that when we add or subtract, we simply combine like terms. The thing to be careful of is when you have a minus in front of a parenthesis. You have to remember to use the distributive property. These are the things you need to know about working with polynomials.